Hi guys, Miss Cochran here, and today we're in our trigonometry packet part 1, page 5. We're going to be finding missing sides and missing angles of triangles. So if you will, let's begin. The first thing that I would always do when I'm doing our basic right triangle trigonometry is write our little mnemonic at the top of the page. You can do your SOHCAHTOA, you can do your Tom's old aunt sat on her cat and hollered, or your see one hippie catch another hippie tripping over apples. Okay, say no to drugs. Now, number 1, if you're writing this trig problem, the first thing that I would do is kind of locate and label. When we're locating and labeling our problem, I would use the angle that's given, even though I know we could find the others. So I'm going to use the angle 64 and not the angle over here that's kind of unknown that I would have to find. If I use the angle 64, I'd start identifying our pieces, and X is opposite, and the 25 is our hypotenuse. So, and then I would think about what would I need to use. We have an O and an H. Well, if we use our O and H, that would be our sine uses O over H. So I would set our problem up, sine of 64 equals the O number, which is X, over the H, which was 25. Now, I'm going to just go through a couple of these, setting them up. So let's set up number 2. Can we write the trig ratio? What angle would I use? The 47, okay. What is the X? When we label, what would our X be? It's our opposite. And what is the 12? The adjacent. Okay, so I need to use O and A. Well, if we use O and A, this problem is going to use tangent. That's good. So we're going to do tangent of the 47 equals the O number, which is X, over the A number, which would be our 12. And that problem is now set up, ready for us to work. Now, let's do number 3. Can you set this one up? Okay, what is the 34? It's our hypotenuse. Okay, what is the X? It's our adjacent. So what uses A and H? Cosine. So how would we write this one? Very good. Remember that next to the little word is always your angle. Okay, always the angle. Now that we've got a few of these set up, I want us to actually go back and solve them. Okay, and I want to talk to you about your calculator. And notice the 64 is degrees, and notice the 47 is degree, and the 18 is degree, and the 35 is degree. This is important. Most of the time when you reset your calculator, its default is radian. So my calculator is not set up for me to do these problems. What you need to do, if yours has the wrong word, okay, we need it to say degree, not radian. We need to press the mode button next to that blue key. We can scroll down. Notice that the radian is highlighted in black. We need to scroll over to the degree word and press enter, and now it is highlighted in black. That resets it to the degree mode. But now to get out of this screen, we can do second and the mode button to quit it. Second mode quits the page. So now our calculator is in our degree mode and ready for us to use and for these problems. Okay, so now let's go back to problem number 1 for a moment. And if we're solving for letter X, how do we get rid of 25? We multiply by 25. So we're going to multiply by 25 on both sides of our problem. 25 cancels. and you get x equals. Now notice it's not 25 times the 64. Okay, it is 25 times the sine of 64, and you can type that right in your calculator now. So I'm going to go ahead and press 25. You can either you can put the multiply, or you don't have to. You can just go and press the sine button and 64, and it automatically knows to do the multiplying. So press enter, and our answer is 22 point. It said round to the nearest tenth, so it is 22.5 for our problem number 1. Now, if we go to problem number 2, how do I get rid of the 12 and solve for the x? Multiply by 12. So if we multiply both sides by the 12 cancels off on this side of the problem, giving me x equals, and now I can just plug this in to my calculator. So you're going to do 12 tangent 47, and you end up with a 12.9 for your answer for that side. Okay, remember these are sides of your triangle. Okay, so move into number 3. Again, how do we solve this one? For letter x, multiply by the 34. If we multiply by 34, your 34s cancel on that side, and then you can type this in your calculator. So 34 cosine 18, and we get a 32.3. Now, number 4 has a little bit different math. You still set it up doing the same trig ratios, identify and label your pieces. So we're going to use angle 35. 9 would be the opposite. X would be adjacent. And what uses O and A? Okay, it is our tangent. So we're going to use tangent of 35 equals the O, which happens to be 9, over the A, which is X. So when we're solving this one, the solving can be a little different. There are 2 ways to solve it. We can do like we've been working them, but you don't multiply by the 9. That is incorrect math. It's not dividing by 9, it's actually dividing by X. So you can multiply by X on both sides of your problem. That makes X kind of move to the top of the problem. And then you guys can divide by tangent 35 to move it away from your letter X. Because they were multiplying, you can divide by tangent 35. That cancels. And then you can put 9 divided by tangent 35 into your calculator. It ends up giving us a 12.9 as the answer for that side length right here, that adjacent side. That's not the only way to do that problem. Let me go back for just a minute. And we had the tangent 35 equals 9 over x. Some students will like doing their math problem this way. You can put a 1 under your tangent 35, and you could have just cross multiplied. If you cross multiply, 1 times 9 is 9. You would then bring down your equals. You can multiply x times tangent 35, and then in order to solve for x, since they're multiplying, you would divide by your tangent 35 to move it. You still get the exact same answer. When you put that in your calculator, it's the 12.85, which rounds to 0.9. But that's just an alternative way to solve it, that you can put a 1 under, and you could have cross-multiplied. Now, some students prefer this method over the other one, but you guys can choose how you want to solve your algebra. Okay? So going back to our number 5 now, let's set it up. So what is your 27? It's our opposite. And what is x? It's our hypotenuse. Good. And so what would we use? we would use sine because it uses O and H. So we're going to do sine of 63 equals the O number over the H number. And once again, now some students are going to see the pattern, and when X is on bottom, some students will notice the pattern and they'll go, oh, it just does 9 divided by tangent 35. And over here, when X was on that was the only one, sorry. When X is on bottom, you might just see it's 27 divided by sine 63. You guys remember, you can decide how you want to solve it. If you want to put a 1 under and cross multiply, you would get 27 equals X times sine 63. You can divide by your sine 63 and put this in your calculator for your final answer. So it is 27 divided by sine 63. Ooh, something happened, sorry. 27 divided by sine 63, there we go. And you get a 30.3 as our answer. Okay. We have one more of these to do, and we'll have all of the sides examples complete. So looking at our angle 30, this would be our X would be our hypotenuse, and 18 would be the adjacent. So we could solve this one using cosine of 30 equals the adjacent over the hypotenuse. We know by the pattern that we saw that when we do our math, it's going to give us 18 divided by cosine of 30. I'm going to quickly put that in our calculator and show the answer is 20.78, which rounds to 20.8. But I want to point out that it was a 30, 60, 90 triangle. And yesterday we talked a lot about 30, 60, 90 triangles. And that 18 is really the long leg. And we talked about the long leg equaled the short leg times a radical 3. So we could have divided it by 3 and put on a radical 3. When I divide by 3, that would be 6 radical 3. But that would be the short leg piece. Long leg piece would have been double that, so double a 6 radical 3 would have given you 12 radical 3. And if you happen to check 12 radical 3 out in your calculator, you will see it is the same answer as the trig answer that we just did. The difference is the trig is going to give you decimals, and that 30, 60, 90 gave us an exact answer. So it's kind of cool that we can see that both ways in this problem. So some of you might have liked to use the 30, 60, 90, but others may prefer the trig ratios. Now we're going to go to a different type, and we're going to start finding angles. Now they show how to get rid of the word sine. We actually do sine inverse, and that makes the sine cancel out. Over here, cosine inverse will make the cosine cancel off of theta. And on this one, tangent inverse will cancel out the tangent, leaving us the theta equals tangent inverse of x. So it's kind of just showing you the math that you can do in your calculator, but we'll work all of these out on 7 and 8. So let's begin. You do it and treat it just like you did the 1 through 6. You're going to label and set up your trig ratios. None of that really changes. So if we label it, what is 8? It's opposite. Good. And what is the 14? It is the adjacent. So what uses an A and an O? Tangent. So we're going to set this up. Tangent of the angle theta equals your opposite over your adjacent. So 8 over 14. Now in this problem, it's a little different the way you enter it in the calculator. Okay. You already have the answer, and it's like you're going backwards to find out tangent of who is 8 over 14. So you're kind of working it a little bit backwards, but again, to get rid of the tangent, you're going to do tangent -1 to make it go away. If you do tangent -1 on this side, you're going to get your theta equals tangent -1 of 8/14. And that's what you enter in your calculator. So to show how to enter that in our calculator, do you see the little -1s above your sine, cosine, and tangent? These are the buttons we'll use when we're finding angles, the ones in blue. So in this case, we're doing a tangent problem. So we're going to do the blue key and then the tangent button. And you don't even have to reduce the ratio. The 8/14 does reduce. You could if you want to, but that's extra math that's not necessary because we're typing it in our calculator. It can handle any of the numbers. So 8 divided by 14 is what I'll type. Press enter. And you need to remember what we found. This is the angle. So it does say round to the nearest tenth. So when you find this answer, your angle is a 29.7 degrees. Okay, and that is our answer for number 7. So let's check out number 8. And in problem number 8, we still need to label. What is our 40? It's our hypotenuse. What is our 38? It is the adjacent leg. Okay, so what uses A and H? Cosine. So we're going to do cosine of the theta equals the A number, so 38 over the H, which is 40. But remember, we're kind of going backwards because we're finding the angle. So we're going to have to get rid of the cosine word by doing cosine -1 to both sides of our problem. It cancels that one out. And this is what we'll type. So I'm going to do the second button and then the cosine button. And then 38 divided by our 40. And when we do that, we get an 18.2 degrees for the angle theta. Okay, our angle was 18.2 degrees. Now, this is how you solve your angles. It's very similar to how you do your sides. The only difference is really how you put it into the calculator. So be careful there. Now we're going to look at page 6, some of the word problems. Okay, and I want to start out just explaining angle of elevation and angle of depression. Angle of elevation, if you will, let's say there's Miss Cochran with her big hair, okay, and I see a bird, okay, and I know you love the art. My line of sight has a horizontal line, and it's me looking up and seeing that bird, okay? And me looking up, this would be when it's above, when that angle is above that line of sight, that horizontal line, that is your angle of elevation, okay? But let's suppose you have Miss Cochran with her big hair, and I see a bug. I'm very scared of ticks and fleas and bed bugs, so yes, I would probably holler, okay? But there is my line of sight, and I see a bug. Oh no, this would be, because that's below the horizontal line of sight, this is an angle of depression, okay? So that's me seeing a bug. So you got your angle of elevation and your angle of depression. And again, that's me looking down. Now, if you guys will, now let's go to problem 11. And in problem 11, it is stating the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? Okay, so you'll have to really appreciate my art. Here is my boat. Here is my lighthouse. It will kind of look like a little mountain. We'll have some, it's flashing. This would be sea level. Now, it said that the boat sees the top of that lighthouse at a 5-degree angle of elevation. So that boat is looking up and seeing the top of that lighthouse. It then told us the lighthouse is 161 feet above sea level. So from here down, this is 161 feet. It did ask how far is the boat to the lighthouse. So you're really looking for that number here, this piece here. It is a little right triangle, with the right angle being right there. So if your angle 5 is what we're looking from, then opposite is your 161, and adjacent would be your X, the piece we're trying to locate. So we're going to set this up. Which one used O over A? Tangent. So we're going to work this problem. Tangent of 5 degrees equals the O over the A number. Okay. And then we're going to solve this. So you have multiple ways to solve it. Is there a preference on how I do it? Do you want me to just multiply by X or divide or put a 1 under it? Put a 1 under it. Okay, if we put a 1 under it to cross multiply, you're going to get X times tangent 5 if I go that way. Then equals a 1 times 161 is just 161. Then we'll simply divide by our tangent 5 on both sides. And we'll end up with X equals, and let me go to my calculator. We've got a 161 divided by tangent 5 degrees. And our answer is 1,840.2 feet. That is the distance of the boat to the lighthouse. Okay. Now, let's look at one that is an angle of depression. So go to problem 14 with me. And it says a fire is spotted from the top of a 125-foot tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? Well, here's Miss Cochran's beautiful tower. Here is my fire. It said the fire was spotted from the top of the tower. So from that top of the tower, looking down, we had an angle of depression of 19 degrees. It said that the tower was 125 feet tall. So from here up is a 125. There's my right angle. It wanted to know the fire to the base of the tower, which would be along this piece here. We're trying to find X. Now, this one is a little unique because 19's not inside like of the triangle here. You can use a lot of different rules. Many students like to just look at the rectangle, and if you kind of envision a little rectangle right here across, X, you could move X here because you know a rectangle has opposite sides that are congruent, and that 125 you could actually move right over here and use this triangle, okay, that's kind of dotted with the 90 degree being up there. So your 19, you could write it this way. You could do the opposite and the adjacent. So that would be tangent of 19 equals the opposite is 125 over its adjacent is X. And you could solve it this way. But there's also another way to solve it that a lot of you guys might really like. So let me add in one more piece and talk about, remember I said it's like a rectangle. Guys, this is a right angle. So if that piece is 19, this is 71. you could have used the angle 71 and did the opposite as x, and its adjacent is 125. So a different way to work it would be to say tangent of 71 equals the opposite x over its adjacent 125. Both of these are going to give you the same answer. It's kind of neat. And there is even another thing that you could have done. Does anybody remember alternate interior angles? Where that 19 sits, this angle right here, this 19, is equal to that one right here. So you could have moved the 19 down bottom and used it that from this triangle. It would still be the same setup, but you're just looking at the picture in different ways. Now, I knew I drew a whole lot in this, but let's do the math. If we're over here on this one, it's really going to take that 125, and it is going to divide it by tangent 19, which gave us a answer of 363, okay, and it was in feet. And if we do it using this one, you would have actually multiplied by the 125 to that tangent 71 to solve it, and notice it is the same answer. Okay, so there are different ways that students can use their diagram and solve that problem. Okay, your assignment is to complete pages 5 through 8, and let me know if you have any problems.